Then put it down. Get it here now. Idiot. Shut the fuck up. You've only hurt me. I fucking tried to get you to use the playground. Fuck you. You feel all day. You calling your name all fucking day. And you've been calling your father all day. Yes, you have. Okay, what is it when you say this? What I say this is? What is that? What is that? You told me that what I said was wrong and not true. What is that? I'm calling someone my father. Then stop. Think about it. You didn't explain it enough to me. You didn't explain it enough to me. Then stop it.
Hi everyone, this is Misty Jacobson here, and I just want to go ahead and welcome you all to our presentation today on industrial control systems basics. We have a pre-recorded session for you that we're going to play here in just a few minutes, but I wanted to let you know of a couple of features first. In your questions box, you should be able to submit questions that we will address at the end of the session. And then we will have our instructor, Gary Finko, on live to answer any of those questions with time permitting. So we'll try and get to as many questions at the end of this as we can. Just know that if your questions aren't answered, we will do our best to follow up and answer those later. So without further ado, I'm going to go ahead and push the play button here, and we will get started. Thank you for joining us.
Hello, and welcome to the Industrial Control System Basics course. My name is Gary Finko, and I am an instructor for Idaho National Laboratory. Prior to joining Idaho National Laboratory in 2005, I worked for ABB in Sugar Land, Texas for 20 years. We designed, built, and installed SCADA EMS systems for electric utility. I was introduced to INL when I was assigned as project manager to have ours EMS system assessed for cybersecurity vulnerabilities at the end of 2003. While working on this project, position became available at the laboratory, and I joined the lab in February of 2005. The next slide is CyberChamp. This slide was covered by Dr. Staley during the virtual spring meeting last week, and it maps the maturity level for your organization. This presentation today is an introduction for those who are not familiar with the ICS environment and falls into the fundamental bracket on the right-hand side of this slide. During the meeting last week, some presenters touched on topics that I will cover today, but they covered them at a more in-depth level. Continuing education credits will be awarded for taking this course today. You will get 0.1 CEUs for completing this course. Industrial control systems. I like this definition. Any system that gathers information on an industrial process and modifies, regulates, or manages the process to achieve a desired result. On the right-hand side, we have 6 of the more common industrial control systems that are used throughout our critical infrastructure. What is the difference between information technology and operations technology? Information technology refers to anything related to computing technology. So what IT systems are you using? If you said email servers, employee workstations, desktop, data servers, database servers, all of those are considered IT computers. OT technology refers to systems used to monitor events, processes, and devices, and make adjustments in industrial operation. IT systems relates to any computing technology, so even the systems within the OT technology fall under the umbrella of information technology. Let's talk about supervisory control and data acquisition. These systems can interface with other ICS control systems, such as distributed control systems, process controls, and EMS systems, which is what my company did. We went and incorporated the SCADA system and interfaced it with our EMS system. These systems cover large distances and are used in the electric, oil and gas, the water and wastewater, and for goods and people. They also interface with field controllers, and we will talk about these field controllers later in the presentation. Distributed control systems. These were independently launched by Honeywell and Yokogawa in 1975 and were initially developed to support large process industries such as refineries and chemical plants. DCS controllers are distributed throughout the plant, hence the name, distributed control system, and typically deployed at site facilities. DCS systems are typically a single vendor, a solution for field controllers in DCS through the software that runs on these servers and workstations. In addition, the DCS vendors also provide the hardware, networks, and ongoing support. The HMI software is tightly integrated with the DCS controllers as a result, and the communication networks are fairly simple to set up, although this architecture is not as flexible as that used in SCADA systems. Process control systems, PCS, consist of computers, process control equipment, communication networks, and algorithms for maintaining the output of specific functions of process within a desired range. Some people, sometimes they consider PCS systems as a hybrid between SCADA system and a DCS system. The architecture is similar to SCADA systems, but they perform DCS-type functions. They're used in site facilities, water wastewater treatment plants, automotive manufacturing, and chemical plants. They also communicate with field controllers using plant networks. Energy management system. These systems are a series of processes that enables an organization to use data and information from the field, from your SCADA systems, to maintain and improve energy performance while improving operations efficiency, decrease energy intensity, and reducing environmental impacts. Energy management systems manage the generation and distribution of energy across the grid. They improve energy performance using load forecasting and load shedding. They also do that through weather monitoring, that they can go and understand what the forecast for energy was based on previous same-day load or same-day weather. They also do economic generation determination. They understand what it costs to bring on generation. So if they know that they're going to have a larger load, then they go and determine what is the most cost-effective generation to bring online. Renewable energy. Today, with renewable energy being introduced into the grid, the EMS system is used to understand, based on weather, time of day, and load, what type of renewable energy will be available. So if we know it's going to be raining and it's going to be cloudy, they know that they're not going to get a lot of energy from solar. But if they are going to have wind because of possible heavy, not overly heavy, but wind in the forecast, they know time of day when the wind is available. They're going to have to go and figure out how to balance that into the energy and then take some generation offline because they have to go and incorporate renewable energy. Automatic generation control. This is used to go and maintain the frequency of the grid. One of the problems that we had with the 2003 blackout was that by having the load drop in Illinois, the frequency of the network dropped, and because of that, that went and changed load frequency across that whole area, and that's how different networks started to drop out of blackout. Network modeling defines system parameter, pricing nodes, and marketing scheduling in order to understand, like I said earlier, what we need. what's our economic generation. State estimation is an algorithm to estimate what is the state of the electric system based on the topology model for that utility or for that asset owner. They need to understand what their load's going to be, what's available, and they run an algorithm that goes through and does that estimation and contingency analysis, what ifs, in order to power system planning. Automation system, they're cost effective, they're standalone, they are used a lot in warehouse, inventory control, smoke control, HVAC. Large organizations, large companies, they have automated systems for heating, ventilation, air conditioning. Lighting is also uses automation systems. Patient monitoring. You wouldn't think that. That's a small system. I worked on patient monitoring at Abbott Laboratories back in 1989. Then you have robotics. Those are automated systems. In your smart home, all the appliances that are within the home, talking to a centralized maybe thermostat or a centralized controller, intrusion detection, home alarm systems that now interface with your phones. All of that is automation systems. Here's an example of automated system that's in place by Amazon, and it's in Staten Island where they have Amazon warehouse. This is pretty intensive automated system. Think about how it worked. Think about what things did you see that were automated. If the process came down, what would happen? Could they manually fill the orders? What would they be vulnerable to attack or compromise? Where would they be? Some of the things there, I look at that, I watch that, and I go, wow, to get into that automated system and then start making some changes, manipulations, that could be very devastating. Safety instrument system. We will talk more about this when we later. So I'm going to go and just cover the first portion, specifically designed to protect personnel, equipment, and the environment by reducing or preventing the likelihood or impact of an emergency event. We usually talk that safety instrumented systems are safety umbrella or safety envelope. control systems operate within certain parameters. And as long as they operate within those parameters, everything should be fine. Once the system, for whatever reason, violates those parameters or steps outside of those parameters, it's the responsibility or the job of the safety instrumented system shut down the process, shut down and contain whatever has gone outside the bounds of safety. Those systems are there for that purpose and are generally used in very damaging environments such as nuclear, chemical, refineries, systems like that, where once they go outside of safety boundaries, there could be very catastrophic effect on the environment. So we'll talk more about that later. Here's another video where we'll go and start talking through the ICS architecture. What devices are in there? What is their function? How do they interface with other devices? Finally, we'll talk about the safety instrument system. With that, let's start.
And this is about an hour video.
Shown here is an example control system network diagram. Please note, this diagram does not include a connection to the DMZ via a firewall. It is only an example. For proper industrial control system network layout, see the Purdue model or 3-layer architecture models. Let's look at the different components. At the uppermost level, support servers oversee and direct the lower levels. As with traditional IT systems, many types of servers support a variety of ICS operational requirements. Let's talk about a few. First, historical data loggers, or historians. Historians are servers used to collect and store near real-time process information, which can help engineers, operators, and technicians make better decisions, trend and analyze system behaviors, and potentially predict future requirements. Furthermore, the historian helps operators and engineers ensure safe and reliable operations of their equipment. Next, application servers. Application servers are used for process control, process view, alarms, event monitoring, and other functions. They support the command and control function in automated systems by collecting data from the process, along with other external sources, and performing complex calculations to optimize functionality. For instance, an energy management application requires pressures, flows, and tank levels from the control system, as well as weather data and electrical pricing information to generate pump schedules for water distribution. Its objective is to reduce electrical pumping costs while providing water to the customer. An application server can also collect critical data that an operator needs, process it, and serve it up to the requesting human-machine interface, or HMI, for them to analyze. Other examples of ICS servers include Supervisory Control and Data Acquisition, or SCADA, front-end processors, or FEPs, and database servers. These servers collect and aggregate data sent to the HMI, engineering workstations, or any other servers that store or process operational data. Engineering workstations interface with servers to accomplish engineering tasks such as to modify or to configure a database or program a field controller. As mentioned previously, an HMI, or human-machine interface, is the user interface that provides an operator a graphical view into the process. HMIs generally come in two forms: a touch panel, for example, handheld devices or panel-mounted displays, or software-based applications that are loaded on a personal computer or workstation. Regardless of the form, operators use HMIs for controlling, monitoring, alarming, and trending processes. HMIs, along with all other key system elements, provides a mission-critical role in control system operations. Field controllers are the devices that interface between the HMI and field devices. They coordinate field device actions based on direction from the HMI. They can also send process data and statistics from field devices to the HMI. Four common field controllers include remote terminal units, or RTUs, programmable logic controllers, or PLCs, programmable automation controllers, or PACs, intelligent electronic devices, or IEDs. RTUs are typically used to transmit data into the system, typically over long distances, for processing, and, if required, alters the state of the system using its onboard logic. Additionally, RTUs convert analog and discrete measurements to digital information. They contain analog and discrete inputs, provide numerous communication options, perform data concentration, and provide protocol conversion. RTUs are capable of executing programs autonomously without involving the HMI. This enables RTUs to respond quickly to emergencies without operator input. For example, if the RTU's program sees a high flow rate on one of the input flows, it can issue an output command to shut down the pump. The PLC was originally created to respond to the needs of the automobile industry. In the 1960s, the automotive industry used relays, timers, and switches, along with extended wires to control their assembly lines. Every time a model changed, the assembly line had to be torn apart and rebuilt, making the process of auto manufacturing incredibly expensive and time-consuming. In 1968, General Motors issued a request for proposal to replace the vast hardwired relay systems with a computer-based system. A company called Bedford Associates won the proposal and created the PLC, originally called Monocle, or Modular Digital Controller. Over the years, the functionality of the PLC has matured, and they are now found in other industries and sectors. PACs are a new class of field controllers. They combine the best features of RTUs, PLCs, and distributed control systems, or DCSs, to make a universal controller that can be used across multiple sectors. IEDs are used by the electrical sector to monitor and control electrical power devices such as circuit breakers, capacitors, and transformers. Common types of IEDs include protective relay devices, load tap changer controllers, circuit breaker controllers, capacitor bank switches, recloser controllers, and voltage regulators. Field devices are responsible for the moving parts. Outputs, such as control valves and circuit breakers, control the physical process, while inputs monitor processes and communicate with field controllers via sensors built into the instruments. These sensors convert physical parameters such as temperature, pressure, level, flow, motor speed, valve state, or breaker position to electrical signals. Some of the more common types of sensors are discrete sensors, which support binary events including alarms and statuses, analog sensors, which measure continuous processes such as flow, level, or pressures, digital sensors, which contain microprocessors capable of being programmed. As mentioned previously, output devices control the physical process. Like input devices, the types of output devices can also include discrete, analog, and digital devices. For example, the field controller sends a signal to an output device, such as a circuit breaker, to open a breaker, cutting power distribution to a power line. Lastly, safety systems. Safety systems consist of hardware and software controls used to provide protections and avoid adverse safety, health, and environmental consequences. The specific control functions performed by safety systems are called safety instrumented functions, or SIF. These functions provide a defined level of risk reduction, or safety integrity level, for a specific hazard by automatic action using instrumentation. There are other control system components we have not discussed, but we have introduced the basic principles. What we have learned to this point will provide us with the background needed to further discuss ICS cyber risk. Thanks for watching.
Very good. Based on the components that were in the last diagram, think about what are the most important components within your ICS environment. Each one of you, that may be different based on however your environment is set up. So let's look at some common ICS cyber vulnerability. Plain text traffic and open protocols. We see that all the time when we go in, we get on a network and start scanning, building up and looking at what the traffic is. We find that a lot of the information is in plain text, and the protocols that are there are available out on the internet. We have devices, we have capabilities like Wireshark that will go and look at a PCAP file, which is a file that can be retrieved from sniffing the network, and it will go and show us in plain text what the communication is between devices. The systems are susceptible to denial of service. Even when we go out and try to look at what to use to go and investigate these networks, some of the tools that are available, we go and say don't use them because the systems in the ICS environment do not have the CPU capability or the compute power in order to sustain the tool is used to investigate what is on that system. These systems, because they're old and legacy, probably haven't been patched, or they haven't been updated with patches that would preclude them from being susceptible to buffer overflows. They use either weak or known password. Last week, one of the presenters showed us that default passwords are a big issue in control systems. Absence of embedded countermeasures. What is available? These systems were not built to go and have those types of capabilities in them. Hopefully, working with the vendors today, they will start looking at what they can do to incorporate embedded countermeasures such that these systems will not be that susceptible to cyber attacks. Very dependent on underlying operating system. Our system relied on utilizing the system BIOS, computer BIOS, in order to manipulate things, in order to utilize on the platform that it's on. That's why it's very difficult to take and replace the software on an existing platform, because the software, the applications were all tied into the operating system. And generally, if you want to go in and do anything, you have to do a forklift replacement. You have to replace the software and the hardware in order to go and make sure that your applications will continue to function. Advanced features, whenever they're put on the system, expand the vulnerability landscape. So as you add new things without having them hardened for cybersecurity, it makes it easy for them to go and be compromised, be very vulnerable. And contemporary IT measures, not always the best fit. We talked before about IT technology and OT technology. The tools that are available, countermeasures that are available for IT, may be able to be used in the ICS environment, but that has to be tested and make sure that the functionality is still there once we start using those different types of countermeasures. As we can see in this depiction, this was traditional isolation for ICS. Everything on the top was part of the corporate or business network. And then you can see there was no connections, no outside connectivity, and no connections to the business side of the environment. And because of that, we always talk about it being air gap. Then what happened? We started going and connecting things. The business said, oh, we need information from the control system space. So then we started going and making connections. And as we started making connections, we didn't really think about what that would do to affect our control system environment. We just made sure that the information and data that was being asked for was being sent to the business side. Then this is a better picture of what we had once we started going and making connections. And the connections were inside, outside, all over. In the beginning, we didn't really have those firewalls in place, and didn't have firewalls that were available for wireless or for phones. And being able to put different types of firewalls in between the control system environment and the communication to the outside world. As we started to develop and implement communications, this picture was unfolding, and new things had to happen, and new things had to be brought in order for the environment to then be better protected against outside influence. One of the presenters last week talked about Shodan and how we have systems that are connected directly to the internet. So they didn't have these types of protections. They didn't have firewalls between the devices and the internet. So those are the types of things that need to be looked at in your environment. Do you have any type of outward-facing equipment, devices that are being directly connected to the internet? If you do, you need to go and put some type of protection, some type of firewall, or some type of jump box in between that and your control system environment. Especially today with the IIoT, the Industrial Internet of Things, we are connecting field devices through IIoT into the cloud and then into our control system data gathering environment. So we're not going through any type of firewalls. We're allowing the cloud to be our firewall or our monitor so that people aren't taking advantage of those communications to get into our industrial control system. So what are the inherent vulnerabilities? This one's just looking at the control environment. We have trusted access in between, even other facilities, operation facilities, business partners, vendor support that allow them to get into our environment unencumbered and not go through any of the checks and balances that we require in order for us to feel more secure. The protocols that are there, as I said earlier, these are available. They're commonly used across multiple sectors. And you can go out on the internet and download the protocols and how to go and investigate. I mean, last week we had one of the presenters talk through Modbus. They talked through TNP, and they also talked through some of industrial protocols like Internet IP, industrial protocol, or Profibus. And those are the types of things that they said last week are available out there. If you want to learn about it, just listen. And then, because these systems are old, they're out there, they're like
Another one of my fucking honeys! Another one! You fucking ruined another one! Breaking everything. Not fair. What did I do? What did I do? No, you're cutting yourself. Did I? That's why I put on your sweater. Everything. Ow! Yes. God! Stop me right now! Fuck off with me! Get the fuck away from me! Quit fucking attacking me! Get away from me! Get away from me! No! Yeah! For what? Stop it! Get away from me! Stop it, please! You stop it! You are doing this! You psycho! I wasn't doing it! Please stop! I'm not trying to listen to you. I'm trying to make it to you. Stop it. No. Stop it. Please. Stop it. Please. Please. Stop it. Please. Jeremy. You won't stop. I said stop. What happened? I wasn't doing anything. You out the ground. No, I think you're putting away from me. Get out. Yeah, getting you the fuck away from me. It's back to me. You can't leave. You can't leave. Get out of me. Get out of me. Get out of me. You live with me, something. No, you. Yeah, that's it. Stop pushing. Yeah, hey, you. You did that. You fucking did that. You are the one who was going into it. You were slamming into it. That was me. No, it wasn't. You fucking liar. What, you don't love me at all? Yeah, I do. If you don't love me, I do. You just everything else. Have you tried to stop it? No. call them anytime you need one. Call our board. All right. No problem. I'm going to put this. And I commented on what tell me to go with it. Now I'm good to see it and she got me on that side. That was right. She put down my name. And you have to go to do it. I hit the horse down in the house. Because it's, I earned this certificate that I passed for fine code and it's weird about bomb units of bomb making materials and it's not supposed to be there and I passed it. Accidental terrorist. Yeah, it's kind of funny. Good. At least I know what I'm doing. So if I know what I'm doing, that means I know what I'm looking for and be aware and help others. So, Homeland Department. Yeah. Homeland Security, yep. Or TSS. Or FEMA. FEMA is Federal Emergency Management Agency. Or CISA for cybersecurity. This is what I'm learning at this moment. This course is an hour to easier.
Legacy, they have software vulnerabilities that maybe do not have the vendor rules even available.
You could call my printer if you
or
need
they're
any
on
form
systems that are no longer.
as well.
These are the software vulnerabilities. We have firmware vulnerabilities that we can out there. These are all inherent in nice things. What's the root cause of this? As just mentioned, legacy control system, migration to information technology,
You just don't have much time.
moving to communications, integrating what's that segregated environments to business
And most of that
environments.
one asshole
And then connecting
also
our
has
environments
twice
to the outside.
the vegetation cord, like colors.
Internet. And
Minus
then
one thing.
cybersecurity.
FBI had a female.
That is not
That one
inherent
didn't.
in cybersecurity. That
Oh,
is something
The
that
secret
we
agent and
have to
I
go and teach.
did a webcam show. And it got really dirty and got connected and guess what? I got interrupted because the assholes Colorado and
responsibility is the process. Whatever's
one
being
thing.
worked on, they are not
Okay.
concerned
Forgot
about
to sign the form
cybersecurity.
for the
Unfortunately,
Leave.
cybersecurity could
Okay.
be the same thing as
Yeah.
safety
leave it.
and reliability.
I needed
Until
to
they understand that better,
check up
they
for
are
a
gonna be
federal
somewhat
emergency,
In
like
summary, we have
Japan had another typhoon or
IT
earthquake
systems. We
or
talked about 6 of the most common
Kind of,
ICS
yeah.
systems.
or
Connectivity to
tsunami.
ICS components have changed as we collect and analyze.
You know,
and
Japan
process
actually
remote
sunk.
information.
But
And
in the city
ICS
underneath
systems
Japan.
that we prepare for
And it's like, look,
completed the training, and I have a few questions that have been submitted. If you'd like,
just pick up,
raise your hand or continue to submit them. Otherwise, we will complete this training, and hope we'll see you next week for the next session.
Yeah, I have multiple jobs.
See what I have here. I'll
One of
answer
them
people
is,
that come in.
they'll piss off at me. You can't smoke pot or do any other narcotic or other type of drug in the
Searching
government
for our own devices.
federal
Let's
government
show that
area.
would be beneficial.
But
A beneficial
we all
exercise.
beating that odds.
Search for
Don't have the
vulnerabilities.
government already legalizing it
What I'd
for
say
medical
is
marijuana
a slide
or
to show
government
them to see whether or not you have any
stuff like
ICS
that.
devices connected to
Also,
the
that's
internet, which is a
made them
vulnerability
happy.
as far as I'm concerned. You at your company or
First time, I
your
want to send some
facility
paperwork
should
to
not
Washington,
have
D.C.
anything that is
to their Homeland Security
that a tool like Shodan would be able to detect
and do the
and
investigation
deter.
of me.
So
I have to have one.
I
I
would
put
say
everything
this
on
is-
me, for me,
that's a
okay?
good thing to do.
With
It's
my
very
ID
beneficial.
and everything. Everything I ID. Everything works correct.
Next question.
Everything comes back to, he's just an asshole.
Are ICS starting to evolve
Yeah,
to become
Ace is
more
an asshole.
secure?
Because that whole bomb one
That's a
shouldn't
very
been
good
do
question,
bomb
and
making.
we have
I
been
think
working
that's what it
with a number of vendors in
At
different
least
sectors
I
in
know how
order
to
to get them to
when I spell
understand
wrong is
that building insecurity is beneficial. The problem is
But
there's a
no, I
lot of
think that was a screw up anyway.
and
I just
even
like
in
incidental.
the sectors don't have standards or compliance that they have to,
Computers,
and because of that, the asset owners
yeah,
are
don't sound
not
crap.
asking for systems to be secure.
The different colored hats.
The ones that I
or
am
this.
seeing
Mine's
working
white.
harder to go and secure their systems are the ones that have standards in place and now
It's
these
accidental.
asset owners need to go
I
and be
don't think so.
compliant and meet when they get audited. So we see this for electrical because they have to be compliant with
We all
their
have
SIP.
a
We see
way
it
of
in
just
chemical because they have standards that the systems have to meet. We're working right
I'm my
now
own
with
unique
water
way
and
to
wastewater, and they're
figure out
setting up
by
different
repeating
things,
or
different
passing
that
into
their
a
asset owners
grade,
need to comply with.
and I could figure out
Be,
in a way
compliant
that I
against.
step back.
So there are a
Yeah.
lot of companies or a lot of
That's-
industry
yeah.
sectors that
Agree.
are putting together standards, and because of that,
Accidental?
I
No.
believe that the vendors
All of
are
this is
getting
not
on board to
accidental.
go and meet
It
with
was
these.
pain in the ass. Even
Hey, Gary, let's take a
Microsoft
question
and all them.
live from the audience. I'm going to go ahead and call
yeah,
on
that's how it
a
works.
tool.
I just totally forgot that about 4 years ago.
Well, let's see. Maybe not. Maybe we'll try Walter. Walter Clark.
So
Walter, go ahead and unmute yourself and ask your question.
I was wondering if it's possible to replay this as a recorded event and or download a copy of the slides.
That's an easy question. Yes, we will make this available.
available offline for you.
Thank you.
All the questions that have been submitted, I will answer. So you will get the information sent back to you, even if it's after the session has ended. So,
Dave Sutherland. Go ahead and unmute yourself.
Yep, thank you. I was just wondering if there was an opinion on if we're ever going to get to a point where the ICS vendors stop giving a choice to secure environments, or if it's we feel like it's never going to get to where that's just inherent in the product offering, and by using it, you're going to have to secure your environment.
that's a great question. I've been, like I said, I've been doing this since 2003. And at that time, I was working for a vendor, and that was our intention, was to go build in as much security as possible. The problem is that vendors are in the business to make money. And putting things in, generally, whatever the enhancements are, cost money. Once they have it in, then they can give it to other customers for cost, but it takes that development. Somebody's got to pay for that. You have a number of people, a number of customers that want that. Then they can spread that cost across many different systems that you sell. So I think on the ones that are out there right now and have been putting it in for a while, that's going to be,
those two boys
it's not going to be a
told
cost
each other
factor
about
at
one
this
time.
point anymore.
Our general
But
were
the other
never service in
that
a
are
million
there,
years.
and
Guess what
that
happened?
people are looking
He
at
walked
and,
past. He was younger
as I said
than
before,
this.
there's
and
nothing
saluted.
there forcing them to have secure systems. I don't know how that's.
Then the manager. Alright,
I know that's a
yeah,
little
general
long-winded, but
manager
that's what I see.
high risk.
And I think that
But
answers the
that's
question.
a title you have to learn. But yeah, it is. To the judges is the title. It's what you earn.
Do
So
we have any more questions?
if it comes to Baby J
Let's
or
take
Ace
one more
or
live
Jace
question.
or
Sanford
how the
Cross.
hell do you got
Can you
run
unmute
most of
yourself?
Oh, it's easy.
And how do you do that again?
I didn't put a space in it.
You did it.
You did it.
That's the only thing. I didn't put that little
Who
space
does
in
the
it.
recommend that secure communication protocol? I attended the presentation last week, and they talked about problems, but it didn't work the way it was.
I
What
didn't
the
know.
recommendation on that?
This is the bad stuff.
Susan, I missed the first part of
So,
that.
yeah, Sylvia had sent the county.
Do you recommend a communication protocol that was secure?
In which area? Are you talking ICS?
Other,
Yeah.
mother who gave out the pictures of the
But I
angel.
didn't hear one that they recommend security wise.
I know, Angel Street, if you
Okay. This one's
take
going
out
to be,
the bitterness of she wants to kill all men, something.
depending on which
Or she just want to kill me. No, she just want to kill men.
systems you have and what types of protocols are available, then there's some of them have some security options. DNP3 has security options. ICCP has a security option. Other than that, it's how you would go and secure your communications based on whether or not you can put it through something that has firewalls and encryption.
All right. So you can access these portals.
Hope that answers your question. If
You
not,
have DHS mode and log you in.
let me know. If
The
that's what you're-
computer or your device is secure enough for the
Yeah, that
government
was
to allow you to get in.
He had mentioned
Before that, it will show up in the red say warning.
problems with
your device is not entering us, government official, BS. That's why we all do.
There are some firewalls available for the ICS environment.
One house is
If you
just,
send me a question, I can send it to you offline. I don't want to go into that. But once again, it depends what you have available and what you are already talking to. Because if you have a system in place, it may already have communications that are set up that you utilize. I think
Okay, Gary does. Oops.
Yep.
I was just gonna jump back to the chat box for a minute.
okay.
good passing now.
Looks like the next question is, how many ICS systems are usually in a factory?
Your time that says 4 hours, I could do on one.
Okay, that's a good one.
I'm seeing how
Once again, it all
I could beat
depends.
damn
Certain refineries, it would be one,
Why not
possibly
two?
one system.
How long
That's
is that? You took my way, but before that,
because
you could do it by 100
refineries are
times.
so specific. They have a tendency to be single sourced. You, what I
You
did
try later
with
when
the
it's
SCADA
the
EMS
basics.
for large
If you could pass the charges,
asset owners,
you could forget
those were
that.
single sourced. You only had one system.
I got
But if you are in a, say, a municipality where you have
get them in a
water,
and add it up.
have gas, and you have electricity, you may have systems
I'm
from
trying to say,
3
that's
different
what
types
we
of
get.
vendors
Even if
that
you got
come
one right.
into
Figure that one out.
the
That's how we
control
got
center
100.
for that utility,
I was tweaking.
whether it be a city
Yeah.
or a municipality of some sort. And then you have hybrids, where you have different types of systems that are there to do portions of the
Same question.
process. And so they do it in order to
One's
do
higher,
that.
one's lower, one's
When you get into electrical, you get down to distribution, you may go and have a distribution
or just speech type right now.
that
I
is
be born
connected
in
to a
any
SCADA
good of
system
something
or
happens.
a business management system. So there's a lot of different ways that when you get into certain sectors, you have a marriage between a lot of different systems.
Maybe a sacrifice.
Perfect, next question. Where should we start? Risk
I
assessment
should
or
just buy a
maturity
new Audi.
assessment?
That's great, I will.
Um,
Everybody says,
if you go
"Oh,
and
that ain't good job."
if you wanted to hire me, what I do first is
You can do this, and that. Damn it.
in the
I said, I hate
I
cogs.
can't
I hate cogs.
go
Don't worry
out
about it.
and see
That's
what
not a
the
cog.
issues are until I know everything that's connected to my ICS network. So that's the first place I would start. Once you have that in place, then you can go and start looking at what's available, what is there. Look at the
Happy with you.
OS levels, look at the platform levels, look at the patch levels, and start doing your cybersecurity procedures that would help you go and make those more secure. The other thing is also prioritizing what you want to look at first. So that's what I do first. If I were assigned to go out and secure my information.
Okay, let's jump to Rachel D. Would you like to unmute yourself and ask your question? Rachel D.
Yes, actually, this is Sean Lucas, but Rachel signed me up. And Rachel signed me up. I wanted to ask, what is your view on cybersecurity and ICS systems transit? Simply like as we move for more automation in transit, specifically rail transit. Do you feel like that these industries are up to date or like what specific vulnerabilities they may have? Questions on that.
Yeah.
Hello?
Oh, right.
Gary, did you get that question?
Not
at all.
Okay.
Yeah, so I just wanted to ask, as far as like the training system becoming more automated over time,
So employed.
where do you feel that they are in
I
terms of
got my
cybersecurity and their
tax
control systems?
numbers.
Like, do you have any knowledge of like, where the industry is as far as like, how
Instead
they
of double
create
taxes yet.
what they need to work on?
But I'm not real familiar with transit systems as far as being out there having done an assessment or anything else. I know that the air, we're doing it with aviation. And when we first went in and started working with aviation, there was a lot of things that were in place to make it work good. But as far as cybersecurity, that wasn't a big concern at that time. I would think that's probably the same thing with transportation. Since there isn't any standards at this point that they have to meet for cybersecurity, that is probably lacking. And that's just a gut feeling on my belief, not something that I have any real basis, but it's based on historical information from other sectors that didn't have any standards that they had to apply.
Education sex.
Okay, it looks like we have just a few more minutes, so we can probably fill
Yeah, look my whole
a few
name
more
back
questions.
for locker
The next one in the chat box, Gary, is: are there any good estimates on how many ICS systems exist in America?
Yeah, no,
That's
that's nowadays.
I know just from the electrical side, if you electrical asset owners,
I did.
this was not co-ops or anything else. There was over 3,500 asset owners. So if you figure at least one system per, then that's quite a bit. Water sector, there was over 30,000 that I know of the last time I was talking with the water. So once again, that's 10, that's a magnitude of 10 times. So you get into all kinds of different sectors, like last gentleman, transportation. You got a metro system, you got train, you got airline.
Time to do this.
I would think that we're talking billions of ICS systems. So, who was the one? Is it ARC?
That
I think
means
ARC
just
does
using my pin
industry surveys. So they may be a source to go out and see per sector how many different types
It's supposed to
of ICS systems.
after class, you get a job.
Perfect. What is the most common ICS for transportation infrastructure?
But yeah, I suppose if you're like
Don't really have an answer for that. I would think that it would be possibly a SCADA system or something along that line. I think it would probably be a SCADA system. Only because transportation is geographically huge. And you need a lot of input from a lot of different places. But if that's on the question set, I can research that.
And use my hotspot and
Perfect. How do we get folks to understand the cybersecurity culture and how it applies?
I could make a lot of money if I didn't have that.
All right, let's jump over to the live chat. And it looks like Fuad has had their hand raised. Are you still there and available? Okay, it looks like maybe not. So, are there any resources you can recommend to study the ICS basics?
Well, I'll plug ours. We have our DLP presented today, and you can go through and get credit for it also. So if you go to this CISO website, to the calendar, and look for BLP training website, go there and sign up.
Perfect. That's probably a great ending spot since we're about out of time. Like Gary said, he will address the other questions in the chat. And I don't know if you want to add anything else to close out, Gary.
I hope that today was beneficial, and look forward to having you all attend next Mondays. So with that, have a great day, and I'm going to be busy answering questions. So
Perfect. Thank you, everyone.
Oh, that was good. Another thing. Yeah, control system trying to open the physical. Yes. Even second. So I'm just going to throw this shit back into somebody's space. Yeah. And I'm get it up. That's the thing behind what she said. I will typical behind for Jake to see. Jake's. So, but she sounds like me or him, because either way, I should start both of them. But I can't. Brother in arms, sister in arms. Yeah, I should smack both of them, huh? Angel, I don't know. She yells too much. She yells at me too much. She breaks my back. I don't care. That's one. See, I'm known as, yeah, he's the one specific. Yep. There's a reason why if I stay in there long enough, and I'm planning on to, I might just think about another different style. You know that military one I like so well, that Barbara Green? Yeah, that's perfect for that smaller laptop and everything. Can't do much. Next. took me to the motel, and he closed by that I was that was to the walk and campsite. And the next day we did to my place. I had a clean up the campsite because the guys were nice and I did promise her the time she comes back and be clean. And coming up and down a 3 4 steep and 3 4 degree. We talking about mud, logs, compact. It's you and a horse has those shoulders. I hiked that motherfucker up with a 12 pepper washes and crap like that. But uh, combat boots or tactical boots. And I could even do that jumping in my window. I have so much and the front the little pocket stuck out. It's just hanging, just no wood, nothing, no beam, metal, tripod, laying a room building for you. Yeah, I remember that. And yes, yeah, no. I'm back. It's in combinations. Yeah, that's how it happens before the time. And you get some people watching these and some of these now. You're passing it's in combinations and you see it on the head. Yeah, I think that allowed me to run into that was a surprise place. Yeah, I walked into it and they taught me the management point of view. And wait a minute, that's how I knew over the 100. Fuck. Oh no. But yeah, I did earn a certificate from FBI. Oh, CII. Tech information again. You guys, how much skills you have with privacy from DHS. And PII also needs personal information and identity. When that devil say protect information. So, point number one, that's why I show this as privacy. So, this is over schema. I think I actually changed my password. Yeah, cover my value. I'm smart enough to do this. I'm smart enough to because I was one off to become an actual cop without them knowing. I actually changed my name. Literally. I could still use, Ace, their host of differently. Ace Hole is a nickname that the government always likes to say. And me, I got to get from his job site too. You're an asshole. I got that one by doing time management. Anyway, as I'm going flights and everything. Other than the FBI, yeah, the whole Central Western yeah, that happened because of the, yeah, if you connect the dots, I'm not telling anybody, but connect the dots, and you have a bachelor's degree, it says it right there, what the requirements are. And that's what I did with doing myself. And luckily, they offer even school 3 courses. 4 cities equals up to stick with these guys because basically I just hate you. Yeah, to cut it off. This is good. But I know how to come in. Yeah, I love them too. I agree.
Now that we have discussed the risk equation and the different types of threat actor groups, let's take a look at the risk curve as it relates to these threat groups. A risk curve is a plot of the likelihood of an event occurring, which, as you recall from the introduction of this section, is the vulnerability of the system multiplied by the threat versus the potential consequences. On the y-axis, or vertical axis, the plot displays the likelihood of a cyber attack occurring from high likelihood up to low likelihood as you move up the axis. The x-axis, or horizontal axis, shows the consequences increase from low severity to high severity as you move along the right of the axis.
The more benign activities occur in the bottom left-hand corner of the risk curve. For instance, a system scan, referred to as a probe or profiling, looks for open ports. As shown on the graph, the likelihood of such an attack is high, but with significant consequences. In fact, an outward-facing firewall on the internet is constantly probed, sometimes hundreds of times a day, with little impact on the system. Moving along the risk curve, the severity of consequences of an attack increase, while the likelihood of a successful attack decreases. Risk managers refer to the types of attacks in the top right-hand corner of the curve as high-impact, low-frequency events. The likelihood of such an attack is rare, but the consequences could be devastating. Generally, in Group 1's less structured attacks, we see the attack line in a diagonal line with clear correlation to likelihood and consequence. At this level, attacks that generate greater consequence are more difficult to execute. Considering that Group 1 actors usually act alone or in small groups with limited organization and resources, the level of effort increases noticeably as the attack complexity increases. However, the trend changes when you look at attacks performed by Group 2 actors. For instance, the risk curve changes from a diagonal line to a nearly horizontal line. This increase suggests Group 2 actors can increase the impact of an attack without having to exert extra effort to generate the more severe consequences. The motivations of Group 2 combined with an advanced and collaborative technical capability results in an increase in consequence with no deterioration in likelihood. For example, a criminal organization with the monetary power to purchase specific hacking capabilities for a focused attack can have the same likelihood, but depending on the capability of the attackers, can generate greater consequences. The Group 3 attack likelihood spikes on the threat curve, reducing the likeliness of a successful attack, but then plateaus again. Group 3 types of attacks are carefully crafted and typically take years to plan. These types of attacks have very specific goals, generating very specific consequences. And these consequences could be extreme, such as widespread economic impact and the degradation of recovery. The level of effort is Group 3 activities in the high and low frequency domains can be designed to have cascading effects across critical infrastructure sectors.
I won't get on your badge, but if I have a tattoo of my badge, it's permanent. It's super fast going, isn't it? Also, your Christian answers. Some of these. But this is like, if anybody's seen 1993, 95, hackers, with Peter Julian, when I was a kid, he was VHS. Anyway, think about the two separate security guys. Larry and his super safety. He's generally his actual movement. Some of these certificates is meant for that type of guy. I'm more like, not plague, but that dude's like freak. So, or Nikon, or Zero Cool, or Active Program. then you got Joseph or Joey. He's always in trouble. And then we give me the inside of like those payphones. Actually did it. Keep on back then, you keep on tapping on it, and you get operated. In jail, you don't do that. But I tried it in my jail. I didn't try it in here though. Yeah, they're more funny. Sure, I'll play with it. And now, thing with court and look at the computer and the internet. Yeah, I just different connections for those. I think it was the phone receiver here and the laptop sucks. So,
The graph we will develop on this page plots intruder knowledge and attack sophistication over time. The red diagonal line shows that the complexity and sophistication of cyber attacks increase over time. This is obvious because attackers are constantly learning and developing more complex and sophisticated techniques to exploit systems as a result of mitigation strategies that have been developed. Over the course of time, attackers have had to work harder to create attacks that overcome security countermeasures but still provide a favorable outcome. A good way to understand the cyber threat to ICSs is to review the evolution of cybersecurity in the context of attackers and the vulnerabilities they produce. Computers have become more critical to structured operations, and the consequences of cyber attack have also increased. The green curve here will allow us to look